Yes. Yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear, right?
Yes, sir.
Fine. So in the last, we had a demo session, right? So in that, I was just briefing you about PySpark. What is Apache Spark, why PySpark and need for it, Spark, Python, and Scala, and real-time usage of PySpark and PySpark job market. Right. So the Apache Spark was developed by Matai Zaharia in the AMP lab. It was open sourced in the year 2010. It was donated to Apache Software Foundation in the year 2013, right? And it is used for big data. So it was introduced in the year, right? It was open sourced in 2010, and it was donated to Apache Software Foundation in the year 2013. It was developed in the year 2009. It was open sourced in the year 2010. It was donated to Apache Software Foundation in the year 2013. Used for big data analysis and for processing and for computation, right? Yes. Defining Spark means it is an open source distributed execution framework, cluster computed with in-memory computing feature with parallel process style used for large scale data processing. Mainly you can see in-memory computation, right? In-memory computation, right? Computing, right? In-memory computing. In-memory computing means storage happening within the memory and processing is happening within the memory, right? In memory, everything, storage and processing, everything happening within the in memory, right? Parallel process style, parallel process style, right? Okay, cluster computed, parallel processed, in memory computed, distributed execution framework, right? Used for large scale data processing. Spark can be coded with Scala language. Scala, it can by default Spark built by using Scala, and Spark built by using Python. Spark can be coded with Scala. Spark can be coded with Python. Okay, Spark will be coded with Java and OR language. All this multi-language support. Okay. So why PySpark is an Python API to use Spark, right? It's a lightning fast technology that is designed for fast computation, right? Yes, it's lightning fast technology which is designed for fast computing. So it's one of the demanding tool among the data engineers, right? Demanding tool among the data engineers to work with bigger data set. So here why we use for PySpark nut for distributed SQL, right? Like we have got components like Spark SQL, data frames concept, right? Where we make the data structured. Where we make the data structured, right? Yes. And performing some kind of querying on that kind of data. And we have got many data frame APIs available and we're converting to normal SQL statements and performing querying on it. And creating data pipelines. So Spark is a data flow language. So data flow means sequence collection of pipes. So each pipe at least some transformation, filtering, grouping, sorting, aggregation is going to happen, right? So the output of one will be the input to the next flow, right? The output of one flow will be the input to the next flow, right? Ingestion data into database, ML algorithms, machine learning. This Spark with Python, right? PySpark mostly like this used for ML machine learning things, right? And graph or data stream, graph algorithms and data stream, right? So PySpark is mostly used for these things. So we have got many PySpark packages like PySpark.sql, PySpark.streaming, PySpark.ml machine learning, PySpark.ml lib, right? Package, right? Spark So as I said, everywhere we see like a large amount of data is generated both offline and online, right? So we see many hidden patterns in it, unknown corrections. We can see market trends and customer preferences and other business informations, right? So we need, it is necessary that we need to extract valuable information from it. So we require more efficient tool to perform these types of operations on the big data, right? So so already we have got many tools available, but they are not so appealing, right? So we go for scalable and flexible tools like PySpark, right? So we can gain some benefit from it. So the combination of Python and Spark, Python and Spark, combining Spark is an execution model implemented by using a language called Python. Both Spark with Python, we call it like PySpark, would be the very efficient for the world of big data. That's why Apache Spark community, it has came up with a tool called PySpark. It has came up with a tool called PySpark, that is Python API for Apache Spark. Python API for Apache Spark, right? Yes. Python and Scala, right? Yes. So difference between Python and Scala, which one can be mostly used? Most of the strengths will have by default Spark built by using Scala. So even today, like Python is mostly preferred because it has got many libraries towards this ML and graph algorithms, right? It is dynamic typed, means what value you are assigning, based on that the variable gets created. So a float variable gets created, integer and a list will be created, right? As you what you are assigning, based on that the variables getting created, we say like dynamic typed, and these are static typed, and has got a huge community, right? Huge number of libraries available for Python, 89,300 inbuilt modules available. Scala is smaller as compared with Python, and Python contains powerful libraries, right, for ML, graphs, and other things, right? And it is less as compared with Python. PySpark features, right, is in-memory computing, like in-memory computation, storage and processing happening within the memory level. Storage and processing happening within the memory level, right? Yes.
Sir, one question here. So if
Yes.
storage is happening in memory RAM level, so we need more RAM in
Dis-
computer.
Distributed RAM.
Okay.
For example, your file size, your RAM size is, assume each system RAM size is 8 GB. There are 10 systems. Total RAM capacity
80. Okay.
80 GB. Your file size is, think, 50 GB.
Mm-hmm.
50 GB is going to be divided into different parts, multiple partitions. Those partitions are distributed across multiple RAMs of multiple slaves. Means it is not going to be stored in a single system, right? Where you won't see the advantage of parallel processing, right? So your data object is going to be divided into partitions stored across multiple RAMs of multiple slaves and are processed parallelly. So what advantage you get is in-memory computation is one, parallel processing is one, right? And distributed. So yes. So because of this, Spark has got very high speed, right, as compared with the other technologies. Lazy evaluated. The data flow gets executed only when we perform an action. Lazy evaluation means Spark is a data flow language. One flow output will be the input to the next flow. Again, the same thing. That output will be input to the next flow. So lazy evolution means it will be executed only when we perform an action. When we perform an action only, right? Fault tolerant. Multiple tasks executed by multiple slaves. If any one slave goes down, multiple tasks are executed by multiple slave systems, right? If any one system goes down, then the task of it need to be assigned to any of the other available slave. This process is called as fault tolerance. Yes, persistence means transformations can be reused, I said. Transformations can be reused, distributed, and parallel processing, right? Yes, these are the features. See, and real-time usage of PySpark. Real-time usage means, yes, it is used in the commercial sector, right? Yes. So we say real-time processing, we say real-time usage or real-time processing using Apache Spark. Immediately then and there, right? Giving the results. Means if a fraud is happened, right? After 2 days, you are detecting that the fraud happened, but using PySpark, then and there we say like fraud happened, right? Okay. So here, if you see most of these banking sectors, financial sectors using Spark to retrieve various customer social media profile, right? And analyzing or gaining useful insights, which can help them in making the right decisions. Like even in credit risk assessments, targeted ads and customer, right? Yes. Even in the fraud detection, it plays a vital role, widely used in ML tasks, machine learning tasks, right? Yes. So even in the healthcare also, right? Keeping in track of the all the previous medical reports data. So here, if you want the patient's records with the previous history of his medical history, and also predicting the patient which is probably to face that issue or the problem, right? Who has been discharged from the clinic. Also, even you can predict those things, right? We have got ML techniques implemented using this Python functionality, right? PySpark functionality. Entertainment industry also, you may even if you see many OTT platforms also using PySpark, right? Because the rate of speed of processing of PySpark is very high as compared with other technologies. With a very rate of speed, with a very high rate of speed, we can process. Even the industry is expecting very high speed processing, right? Even in the entertainment industry, right? We use like the OTT platform like Netflix uses Apache Spark for real-time processing and for personalized online movies or web series, right? I said, right, in case of this Netflix, nearly 450 billion events per day it processes, right? It processes nearly 450 billion events per day that are streamed on server side application, right? Yes. Even in the tourism industry, in e-commerce and the tourism industry, right? So even like the e-commerce sites like Amazon, Flipkart, even they are using this Apache Spark, PySpark, right? And even for this kind of recommendations, right? And for advertising, providing some offers or enhanced customer experience, right? To and optimizing the overall performance. Tourism industry, right? Even in the tourism industry, right? To provide advices to millions of travelers. Okay. So even I was just giving an example in the previous session, right? Yes. Taking 100 TB of 1024 columns, right? So to check the speed of various databases, right? Yahoo has taken a table of 100 TB consisting of 1024 columns, sorting based on 16 columns. What is it? Sorting based on 16 columns. What is the time taken by various databases? Okay. So the time taken by Oracle database, it has taken nearly 3.5 days to process this, right? And MySQL has taken nearly 6 days. Teradata has taken 4.5 hours, right? And Netija has just taken 3 hours. Netija has taken 3 hours. Hadoop has taken 3.4 minutes. Oracle 3.5 days, MySQL 6 days, Teradata 4.5 hours, Netezza has taken 3 hours. And finally, Hadoop. See, this Teradata and Netezza are kind of specialized databases used for data warehouse purpose. So they can handle huge data. That's why they take only hours of time, right? 4.5 or 3 hours. But finally, Hadoop has just taken 3.4 minutes to process. 3.4 minutes, right? Yes. So that is the speed of Hadoop, right? But PySpark, if you see, 100 times faster than Hadoop. It's 100 times faster than Hadoop, right? Yes. Talk like PySpark, mainly designed for batch applications. Batch applications means user non-interactive applications where user won't give the input. Credit card statement generations for millions of customers. Phone bill statement generation, right? For millions of customers, right? That is mobile bill. So in this way, where millions and trillions of records are involved, batch applications. Second, like iterative algorithms, right? Interactive queries. Interactive queries, right? And for streaming. Batch applications for iterative algorithms for interactive queries and for streaming. And real-time use case of PySpark is for commercial sector, healthcare, all we have discussed. Okay. So you need to know something about these RTDs, right? Spark data objects. RDDs, right? Yes. Resilient distributed data set. This is resilient distributed data sets, right? Yes. What do we call as RDD? Nothing but Spark data objects. Spark data objects, right? Yes. Spark data objects are called as RTDs. Spark data objects are called as RTDs. RTDs are subdivided. Any Spark data object or RTDs are subdivided into partitions. Subdivided into partitions. These partitions are distributed. These partitions are distributed across multiple RAMs of multiple slaves. These partitions are distributed across multiple RAMs of multiple slave nodes and are processed parallelly, right? Yes. If you talk about this in RTD is programming style. RTD programming style, right? Yes. Data flow. RTD's programming style is data flow. Data flow is a sequence collection of pipes. Data flow is a sequence collection of pipes. What is a pipe? A pipe can be any data operation. A pipe can be any data operation, right? Any data operation. Such as loading the data, transforming data. Yes, transforming data, filtering data, grouping data. Merging data, etc. Right? All this data flow is a sequence collection of pipe. At each pipe, a pipe can be any data operation such as loading, transforming, filtering, grouping, merging, all this, right? Yes. Observe carefully in Spark. Data flow is executed. Data flow is executed in sequence. Data flow is executed in sequence. That is RTD by RTD. One after the another. In Spark, data flow is executed in sequence. That is RTD by RTD. One after the another with in-memory computation. With in-memory computation, right? And the persistence feature, right? Yes. So observe this, RTD is executed in sequence one by one. See, one RTD output will be the input to the next RTD, so that two RTDs cannot execute in parallel. Observe here, two RTDs cannot execute in parallel. One RTD output is the input to the next RTD. Two RTDs cannot execute in parallel, as one RTD output is the input to the next RTD, right? Yes. Okay. But if a RTD, observe here, but if a RTD has 30 partitions, if it is had 30 partitions, but in a RTD, but if a RTD has 30 partitions, then they can execute in parallel. Observe this flow, right? Yes. If you want to understand these things, right? If a RTD has 30 partitions, then they can execute in parallel. Observe.
Is 30 the limit? Like
Example, R1 is an RTD. This RTD has got 30, it is divided into 30 partitions. P1, P2, P30. This 30 partitions loaded in 30 RAMs and are processed parallelly. The output will be collected and it will be given to the next RTD2. RTD2, the input will be the output of that previous one. Observe this flow, right? You will try to understand this RTD's importance and this The one thing what you need to understand is persistence, the concept of persistence, right? So here, if I see this, observe this flow R1, R2, R3, the flow is like this, R4, R5. Here R6, R7. R1, R2, R3, R4, R5, R6, R7, R8, R9. So flow 1, what is, see, this is your flow 1. This is your flow 1. Flow 1. R1, see, observe R1, R2, R3, R4, R5. In flow 2, you observe R1, R2, R3, R6, R7. Three flows are like this. If you want to execute the first flow, to execute the first flow, flow 1, executing the flow 1. To execute the flow, we need to make some action. R5 dot action. R5 dot action. If you perform action on that R5, the entire flow executes from the root. R1, R2, R3, R1, R2, R3, R4, R5. When R2 is ready, see here, when this R1 ready, R2 ready, see R1 output is taken as input by R2. When R2 complete, R2 partitions loaded and R2 processed, right? Then R2 will be removed from the RAM because all the RTDs cannot be accommodated by the RAM. And the current RTD processed and computed, previous one gets removed. R3 is ready and computed, R2 gets removed. R4, when R4 is ready, R3 gets removed. When R5 ready, means every time the previous RTD gets removed, right? Final, once the execution completed, R5 also gets removed from the RAM. Now no RTD in the RAM. No RTD in the RAM. Once the final output is collected, the final output will be collected, and what you see in that final RTD also gets removed. No RTD in RAM. If you are executing flow 2, flow 2 means what you will say, R7 dot action, R7 dot action. When we perform action on the R7, the entire flow executes from the root. From R1, R2, R3, R6, R7. When, okay, R1 gets loaded first into the RAM, all the 7 RTDs at a time won't be loaded into the RAM, right? One after the other, the partitions will be loaded. All the 7 RTDs cannot be accommodated. Already one RTD has got larger volume. So one R1 first loaded, then the output is taken as input by the next one. When RT is ready and computed, R1 gets removed. When R3 is ready and computed, R2 gets removed. Similarly, when R6 ready and completed, R3 gets removed. R7, R. Once the total output is collected, R7 also removed. No RTD in the RAM. No RTD in the RAM. Okay. Flow 3. Or 8 dot collect. Or 9 dot collect. Sorry. Or 9 dot collect. Right. Whenever I say or 9 dot collect, from R1 to R2 to R3 to R6, R9. Similarly, here when R2 is loaded and computed, R1 partitions gets removed. When R3 is ready and computed, R2 gets removed. Similarly, this process continues until the entire flow executes. Final output of this R9 will be collected and no RTD in the. You can trigger the next flow to execute, right? So in this way, how this computation is going to happen? If you observe carefully, what is the thing commonly you are observing in all the flows? The first 3 steps are common in all the flows. R1, R2, R3 is common in all the flows, right? Yes. Right. In the above flow, here, each time the flow is re-executing from the beginning. The flow is re-executing in the above flow. Here, each time the flow is re-executing, even though the first 3 steps are common. The flow is re-executing from the beginning. So to avoid this, right, what we do? We need to identify the we need to identify the RTD whose output is commonly used by many different flows. And persist it. We need to identify whose output is commonly used by many different flows and persist it. Can you please, I want the sessions to be interactive. Can you please answer, right? Which RTD's output we can persist here? Whose output is commonly used here?
I think R3.
R3.
R3 output is commonly used by many flows, right? R3's output used by this first flow, second flow, third flow. If you know, this persist this means making the RTD available in the RAM only, so that it can provide output for all the 3 flows for R4, R6, and R8. Okay, so I will come back to this persist, but before that, and
Vijay, one doubt here. Can I ask?
yes.
See, you told that each RDD is divided into partitions and shared across number of flaps. So once these partitions will execute, how it will be again collected by that same RDD and given the output to the next? Can you
So
explain with the diagram?
see here, 1 second. In the already I showed you the diagram, right? Yes. Mm,
The partitions.
on R1 R1 is an RTD data object. Data object means it has got some transformation applied on it. RTD means P1 partition, P2 partition, P3 partitions. On these three partitions, transformation applied. The output will be computed. The result what you get is nothing but R2. Observe. The result you get is nothing but another RTD R2.
But how it is identify that P1 and P2, P3 output will be the R1 output?
No. P1, P2, P3 will perform some transformation. Okay. So here, 1 second. For example, if you are performing some kind of filtering or transformations, you are going to apply some kind of transformations. So here, 1 second. P1, P2, P3. From P1 to P1, you may get all the data or only some specific data. From P2 to P2, from P3 to P3. If you perform filtering operations, only some data you may get. So this new P1, P2, P3. So here we call this as narrow transformation. Narrow transformation means from the same, there is no shuffling involved. There is no shuffling involved. If any filtering, if anything, any other operations, right? If from P1 to P2 data is going, from P1 to P3 data is going, right? It's shuffling involved. Then we call it as a wide transformation. So here, this output, whatever is there. See this P1, P2, P3, RTD is immutable. RTD is what? Immutable. We cannot modify or change it, but you can take its output. Output you will be taking it. R1 output you will be taking as input to R2. So here P1, P2, P3, you will have the number of records will be less than or equal to this P1 of this. Here also less than or equal to P2, less than or equal to P3. So this is what R2. R2 is a new RTD created from this. Understood now?
Sir, one question here.
Yes.
So in one of the notes we have written that RDDs cannot be processed parallelly.
RTDs cannot be processed parallel. Yes.
Correct? So
Yes.
because one output will be input for the other RDD. But in the same notes we mentioned, if it has example, we have taken 30 partitions, then it can be processed parallelly.
Yes.
If I take here, R1 has 30 partitions, R2 has some X partitions. If R2 is depending on R1, then also it cannot process, sir.
R1, see here, you mean R1, R2 can't execute parallelly?
I mean, that's what my understanding from the notes which we have written somewhere.
Yes. R1 first, okay, R1 partitions computes.
Yeah.
After that, you will get P1, P2, P3 as the result.
Correct.
See on the P1, transformation 1 applied. On P2, transformation 1 applied. On P3, transformation 1 applied. So here, whatever logic you are applying will be applied on each and every partitions separately. See, if our data object divided into 10 partitions, on 10 partitions, there were transformational business logic applied.
Okay.
The result you will be getting. Okay, you'll be getting some partitions again, P1, P2, or P3, some partitions you'll be
mm,
getting, right?
mm.
That is nothing but the R2. So R1, see, simply saying R1 dot R1 into R1, if you apply a
Yeah,
transformation
R1 T by R. Okay.
equal to R2. Means, okay, 1 second.
Sir, can you go back to the notes which we written, sir?
Yes. So let me make it clear, right?
Yeah.
R1 equal to, first using the Spark context, if you load some text file, some file1 dot txt, a txt file, you loaded it using Spark context, R1 is an RTD, first RTD created. Observe here, first
sir.
RTD created. On this R1, you got some n number of records. On this R1 dot filter based on city equal to Pune. I want only Pune records. So whatever that output it is written from this is nothing but R2. R1 has got all cities data. R2 will
Correct.
have only one city's data. That is only Pune city. Next, again on that R2, I doesn't want all the entire Pune's data. I
Correct.
want only department number 11, 12, 13, 14 is there. Department 11 marketing, department 12 sales, department 13, some different departments are there. Sales
So that would be
department,
R3.
marketing. R2 dot, again I'll filter. I doesn't want again this entire Pune records. Again, I want a department number equal to marketing department, MRKT, marketing department data only. So again,
Yep.
from that R2, again I'll filter. I'll get
R3.
R3. Means is a data flow from R1, the output is
Correct.
taken as input by R2. And for R2, the output is taken, you perform some, you will get some input to R3.
Input.
So here
Understood.
again, here R1 will have all the cities, R2 will have
Correct.
only Pune. Again, R3 won't have all the departments data, only particular department data. So
Correct.
it's a data flow. It's a data flow. Similarly, like R4, R5 means not only filter is one of the transformation. This way, we have got many transformations available, mapping.
Understood.
So in this way, so this entire flow won't execute automatically. It's lazy evaluated,
Understood.
like functions. If you define a function, until you make a call, it won't execute. Normal functions, right? Here also,
Yep.
until you make some kind of action on which one, generally we make action on the last RTD. R5 dot action. R5 dot action means what happens? One by one RTD gets loaded and finally
Yeah.
computed. But during this process, your RAM cannot accommodate all these RTDs. If all the 5 RTDs to get stored in the RAM, then RAM will be full. It won't, the next flow can't be executed because it won't allow it can't accommodate the next flow. So once the R2 computed, R1 removed. When R3 computed, R2 gets removed, right? When R4.
Sir, one more question related to this one.
Mm.
So if for any reason, if R2 gets fails, okay, so R3 will not run because there is no data for R3 to run. So again, R1 will run to get the data to R2.
For example,
If R2 fails.
for example, R3. So generally, it R1, R2 won't fail. R1 has got some 10 partitions
Okay.
stored in 10 systems, 1, 2, 3, up to 10 systems. Slave 1, slave 2, slave 3, slave 10.
No, sir. I mean, generally,
no. You mean to say
due to
that
network.
your query is wrong.
Okay.
I'll correct it.
Okay, sir.
R1 is a data. Think that some 4 GB divided into 10 partitions. This 10 partitions, P1, P2, P3, P10, right?
Okay.
10 partitions. 10 partitions stored on 10 slaves.
Understood, sir.
This slave 3, suddenly as they are machines, slave 3 is down. System 3.
Yeah.
Means P3 data lost.
Okay. So it will pick from some other slave.
P3 data is lost.
Yeah.
So in such case, what it will do?
It will pick from P1 or P2 or P10.
No. It cannot take. In
Oh.
slave 2, only P2 data is available.
Okay, okay, okay.
In slave 3, P3 is there. All 10
Okay.
slaves storing 10 different
Correct. Okay.
partitions.
Understood. Understood now. Yeah.
So in such case, what happens is, okay, think this is what this is all these 10 partitions belongs to R3. All these 10
Correct.
partitions belongs to R3, assume.
Okay.
R3 still it is not computed, right? Still not executed,
Correct.
right?
Correct.
Observe here, lot of things you need to understand here internally. I'll give you many examples.
Yeah.
R3 is not computed, right?
Correct.
R3 is not computed means R2 available in the RAM or not available?
Available.
R2 available, right, in the RAM?
Yeah. Yeah.
I said when R3 computed and finished ready, R2 gets removed, I said. So
Correct.
now when R3 any partition is down or any system is down, anything is failure, R2 still available in the RAM, right?
Yes.
So,
Yes.
so what it will do is simply R3 what it does, simply it will deallocate all this. Again, it will take output from R2 again in 10 systems, it will store it, other than the system which is down.
Okay.
Understand this? When
Yeah.
any system is down means some number, n number of records, some lakhs of records are lost, P3. So some data is missing means you cannot further go for the processing. So what it will do immediately, what all the partitions they will be deallocated again. Again,
Sir?
it will take the output from R2 and again it will allocate 10 slaves other than the slave which is down. Right? Yes.
No. One more.
Sir,
Sir.
can I
One more.
ask one question?
Yes. So actually this is fault tolerance mechanism, right? With multiple cases we'll be discussing about this. This is fault tolerance we call if any particular thing is down. Yes, yes. Any query you asked, right? You were asking some query. Yes.
Sir, what is the cost of this training of PySpark?
PySpark it is 8K, 8,000.
Okay, sir.
So
Okay. Sir,
okay.
sir, one more
One
question
question.
actually.
Yes.
Yeah, one question. Sir, if suppose if the data we have around 100 GB and the RAM of all the nodes is around 50 GB, suppose can it be possible? Can the Spark execute the data which is higher than the RAM?
Overhead. You will get
Yeah.
you will get overhead error.
So always the RAM should be higher than the execution data, right?
So here your total distributed RAM is less, and your but if if it is less by some, okay, for example, we have got some persistent options are available. Options means like memory only, memory underscore only option, disk only, memory and disk only, memory and disk only. We have got some options like this: memory only. If you use memory only, use disk only, or use memory and disk only. We got these options available. Generally, memory only will be that option. But in such case, if you see memory and disk only, right? If unable to fit in your memory RAM, use your disk. Means instead of the job getting failed, instead of not availability of the memory, right? Use disk. Understanding?
So if it is exceeded, then it will use the disk.
So here, if you give that option, right, memory and disk options, memory and disk only. But if you are given only that memory only option, right? If you have given only the memory only option, then it will be failed. If because of this less memory, right? Because of less memory.
Yeah.
Right? So in such
But
case, one thing is based upon your incoming data, based on your data, right? You need to just the cluster need to be formed, right? With n number of systems in n node cluster, in which the RAM need to be distributed, whatever the RAM you are, right? You need to allocate it accordingly. But still, if it is if you are just your RAM is your totally 10 GB RAM, but there are something there are thing available here. There is some available the things available, right? So either you want to totally go for disk, You want to go for memory, or I want to make use the advantage of memory. As I got memory, I want to use memory if available. Otherwise, go to disk. This memory and disk means, for example, the memory is busy executing other flow. Assume the memory or RAM is busy executing the other RTDs, other flow. As of now, it is busy, but after some time, it may become free once the execution completed. In such case, up to that time, you just execute it in the disk. Later, once it is free, again shift it to the memory and execute, right? That is what happens in this. If you directly give disk only, everything happens in the disk only, right? So I said Spark is 10 times fast, 10 times faster, 10 times faster, right? As compared with Hadoop in the disk level. In the memory level, 100 times faster. In the memory level, 100 times faster. In the case of memory, in the memory level, right? In disk level, it is 10 times faster, right? So understood, right?
Still, I have doubt on partitions. We just suppose this R1 has 3 partitions and it is assigned to 3 slaves. Okay, and the computation is done on the partitions. But how this each partition output is, will it internally merging as a single output for R2? How it is taken as a single output from the 3 partitions?
See, for example, okay, it doesn't mean that all the RTDs should have the same number of partitions. Observe here, it doesn't mean that. One second. R1, is it mandatory that all the RTDs will have the same number of partitions? No. R1 has got P1, P2, P3. P4. Okay. Here, males and females data available, male employees and female employees, male and female employees, male and female employees, male and female employees. Partition nothing but a block, 128 MB by default. B2 block, 128 MB. B3 block, 128 MB. Fixed size. B4 means it, okay, the last one, it won't have something like 80 MB, only some less number. Okay, now blocks means they will have fixed size. So here male females, here if you think 80% males, only 20% females. Here 90% males, 10% females. Here totally 95% males, only 5% females. Here 75% males and only 25% females. Now my R2 is what? Only females required. Only females. Only females means how many partitions you will get? 4 you will get or 1? Here 20, 10, 5, 25.
I think one partition.
One partition. Only one partition you will be getting.
Yeah, but my question here is how it is collecting from partition 1, partition 2, partition 4. Will it apply merging technology or something?
Yes, it will just take only those data. So you are giving filtering condition, right? Filtering condition you are giving only that female data, male gender equal to F. Only those data will be taken as, will be stored in this. That is nothing but R2. So here it will collect only those data from each partition. So P1, the filtering operation, transformation 1. P2, the filtering on for transformation. P3 on the transformation 1. This transformation 1. Internally, it computes. All this will happen parallelly, executes parallelly in system 1, system 2, system 3, system 4. After that, all that outputs will be collected into a single machine. It can be a same machine or it can be a different machine, right? Say that S1. All the data will be collected into a single partition. So everything is a cluster, right? Nodes connected in network.
Yes, yes.
It is everything connected in network. So what do you mean by cluster? Group of nodes connected in a network, 40 node cluster or 80 node cluster. So everything will be collected into one. That is one slave one. Now R2 has got only the one partition. It doesn't mean that all the arteries will have the same number of partitions. It depends upon your transformation. So this we say shuffling occurring here, shuffling of the data from 4 to 1. If shuffling, no shuffling, again we have got a transformations there. Narrow and wide transformation. Narrow means no shuffling. Wide means shuffling occurs. Means between the partitions data will be moving here and there. If P1 to P1 as it is, P2 to P2 as it is, P3 to P3 and P4 to P4, that we call it as narrow transformation. No shuffling occurred. Same P1 to P1, P2 to P2. But here, when P1 to P3, when P1 to P4, P2 to P3, if the shuffling happens, we call it as wide trans. So here everything will be collected into single slave as they are connected in a network. R2. Yes.
Okay. It is not collected by R1, the outputs, right? It will directly collected by R2.
R2. See, RTD is immutable.
Yes, yes, yes.
We cannot modify it or we cannot.
Yes.
So it cannot be changed. Yes.
Okay. Thank you.
Sir, so based on the number of nodes, the number of partitions will be decided.
We can control the number of partitions in Spark. In Hadoop,
Sir.
it cannot be controlled, but number of partitions, while loading the file, you will be loading the file name file1.txt. File1.txt. Beside that, we'll be providing the partitions. How many you want? 10 or 5 or 6. Means it will be loaded into 10.
So it will be decided by us user only.
So means we can load data into multiple partitions we can specify while loading, right?
Sir, if the number of nodes are 10 and the number of partitions are 20, will it be executed?
Yes, executed.
Okay, first 10 will be executed parallel, and then next set of 10 will be executed again.
See, one second. Why 10 systems? In one system also you can execute.
Sorry, sir, I did not get you.
You are saying 10 systems, right? In one system also you can execute, I'm saying.
All the partitions.
So yeah, all the partitions. But we want one thing, what you won't get is parallel processing.
Parallel processing, right.
See here, one thing, P1 is there, P2 is there, P3 is there, P4 is there, P5 is there. 5 systems are there, S2, S3, S4, S5. Full parallel processing, you will get it. Full parallel processing. High speed you can get by because P1, P2. All the 5 will be executed parallelly by 5 systems. As you said, 5 are there. P1, P2, P3, P4, P5. 5 are there. But only 3 systems are there. Slave 1, slave 2, slave 3. Only 3 systems. System 1, system 2, system 3.
Okay.
P1, for example, P1, P3 here. P2, P4 here. P5 here. How the partition stored like this?
Okay.
For example, what happens here when P1 is executing here P2 will be executing. Here P5 will be executing parallelly. Observe here P1 executing, P2, P5 executing. Here P3 will be in waiting state. Here P4 will be in the waiting state. Means here first round 3 partitions executed. Again in second round 2 partitions executed. Means here if it is taking 1 hour time. Here how much time taken?
2 hours.
2 hours it will take. For example, here not 5 partitions. 13 partitions are there. Otherwise, not 12 partitions are there. So what happens? 3, 3, 3, first round, 1 hour it takes. Sorry, P1, 1, 1, 1. So system 1, system 2, system 3. Totally, how many are there? 12 partitions.
12 partitions. 4 hours.
It execute P1, P2, P3, P4. Assume it should execute P5, P6, P7, P8 is stored in this. P9, P10, P11, P12. How many hours taken? How many? 4 hours taken. Means what is your observation here? More slaves are there, more speed, more parallelism. If only one, if for example 3 slaves are there here, assume only 1 slave is there. What is the time taken for 12 hours? 12 hours. But if you've got 12 slaves available, only 1 hour. Okay, so that is what your data.
Sir, one more thing. Previously you mentioned that based on the options we give, memory level or disk level, memory and disk level. There were 3 options, right? So these options will be chosen by the user.
Yes, yes.
Okay. Okay, we can mention. Okay,
So
what kind of
yes,
operation.
yes.
So if we have large amount of data and the size of the RAM, I mean size of the systems is smaller,
if you are able to account, the only thing is Spark, the companies which can afford Spark means you need to afford for huge RAMs, expensive.
Right.
The main thing is Spark will be expensive. The only thing is you need to accommodate huge RAMs. So based upon your data, you need to maintain that much RAM capacity, right?
Right.
If you want, still you can keep on increasing the slaves systems.
Yes.
So you keep on. So generally this Spark will run right this within the cluster, right? So you need to keep on adding the slaves depending upon your data value, right? So understood, right? So
Yes, sir. Got it. Thank you.
Yeah. So this is what. 1 second. So more discussion I'll be discussing, right? This is the course content I'll be discussing in brief, right? PySpark, need for Spark, need for features, web Spark sessions, parallelizing, broadcast variables, and PySpark RTD computations, persistence options, core computations, RTD computations, groupings and aggregations, various actions and transformations, inbuilt actions and transformations are there. Spark SQL data frames, right? Spark data frames API, data frames, right? Yes, PySpark, how to create data frames from different things, right? From row class, from struct field, from column class, select, collect with column renamed, right? Column where, filter, drop, group by, join. All these different data frame APIs I'll be discussing, right? Union by name, flat map, for each, simple, fill, all this, right? And PySpark SQL functions are there. Aggregated functions, and this different types of functions like lit function, when expressions, array contains, right? Different types of Spark SQL functions in brief I'll be discussing. And Spark external sources, from working with pure SQL statements, I want to perform some querying. So like Spark Hive integration, working with CSV, JSON files, narrow and wide transformations, adding columns, right? All this. And local mode and cluster mode, like deployment modes and stages and tasks, drivers and executors, and how the Spark applications, pipelines, deploying and performance tuning, right? These things. Yes. So everything in brief, I'll be discussing about this. So takes like nearly 10 weekends for this.
Fine. So 10 weekends from from today, or
yes.
Already 1 weekend completed?
From today.
So one question, if I know Apache Spark, is it easy to understand PySpark?
Yeah, it will be easier to understand, right?
Okay, so I mean, if I know Apache Spark, I mean, without knowing Python language, I mean,
Python means we are not developing a web application or web application, right? That much of Python we won't be using, right? Basic Python will be used. We are not creating it's not for web applications. Spark or Hadoop is not for creating any web applications or interactive or client server applications, right? It's for batch applications. We won't use that much of Python required, right? Only basic Python. It's not a great thing, right? Basic Python, what is it? You need to know the basics. What is an list collection, tuple, set,
Yeah.
defining variables, that I'll discuss for before I go with the practicals. I'll be just giving you the entire things, right? How we do. That's even
Sir,
Python is not a complicated the thing which can even you can update by yourself also, right?
Sir, you're taking other class also, right? Big data, where you're covering Apache Spark also there.
Yes.
Okay. So if I have that knowledge, I can understand this. I
Spark.
no need to attend this class.
See one thing, Spark will be same. Spark execution model, right? So, but
Yeah.
implementation in Python, implementation in Scala, right? The only the language is going to differ. Means I can implement this. For example, machine learning is there. Or if you talk about not machine learning, if here Spark implementation language is Python, it can be implemented in Scala. It can be implemented in Java also.
Okay. Okay.
So
Okay.
the understanding here, you can implement in different language. For example, you will write a program in C language. The same thing you can write in Java. The same thing you can write in Python also, right?
Sir,
Any C program you can write in Java or you can write in Python in the same way, Spark. But there are some special functionalities, right, available in PySpark. PySpark has got some features available, right? So there is Python APIs available. Okay, so
sir, I am opting for big data course, so no need to attend this course, right?
that there also, if you go for big data, right, Hadoop and Spark, there also
Yeah.
you'll be getting both Hadoop and Spark knowledge, but with Scala implementation. You'll get
Correct.
Python implementation.
If I learn that tomorrow with Python basics, I can understand this one, right?
Yes.
Because I am already learning Spark there with Scala.
Okay, fine.
So no need to go for two courses, right, sir?
Yes.
Can you share the course details? I mean, this list, this content, this one in the chat panel. You will download the code. This.
Pardon? Yes.
Can you share this?
Okay, you'll be getting in your mails, right? Everyone, you'll be getting these things in your mail IDs. Okay. Whatever mail IDs, right? If you will be getting to your mail IDs.
Every day, the number of hours will be?
So it will be for 2 hours on Saturday, 2 hours on Sunday, right? So it will be from 4:30 to 6:30 and 4:30 to 6:30 on Saturday and Sunday.
So it will be for 40 hours content.
Yes.
Okay. Another thing is I'm using PySpark in Azure notebook. I'm running this Spark pool, wherein I have to use that PySpark for data cleaning. And I'm using this df3.with column and df3.select, df3.select expr, these functions.
Yes, yes.
Are we going to include such data cleaning?
Yes, yes. We have got many APIs available. I'll be discussing one by one, all in brief. Right?
And is there an open source available which I can refer for such data cleaning activities?
Yes, yes. I'll be providing all those. So even for your people to execute, right? If you want to do the practical part, different ways I'll be showing you, right? How to execute and how to run these things, right? Yes. Okay. So yeah. So any other queries? We will just continue the session tomorrow, right? Same time, but tomorrow. Yes, yes. One second. And tomorrow there will be the link will be changing, right? You need to get enrolled. You need to get registered, right? Already last weekend you had, this weekend, right? But tomorrow we cannot keep going with this, so we'll be entering into this course, right? Tomorrow onwards we'll be just entering into this, and we'll be doing with the fundamentals of this RTD computations, different RTD APIs, right? Other things. So yes.
Sir, I have done the payment. Will I get the link through my mail ID?
Yes. Anyone, those who are done, right? You don't forget to share your details, right? The screenshot of the payment. Please
Yes,
be
sir.
in your.
Already done, and the team has added me to the
Yes. Today,
Drive.
yes.
Google Drive.
Tomorrow morning you'll be getting the link, right, to your mail. They'll be forwarding to your mail IDs to all the
Actually, I thought that from today itself I'll be getting. So I did.
No,
I did
today,
not.
today also it was given, right? Tomorrow the link will be changing. Only those who got registered and enrolled.
Okay.
Sir,
So you'll be getting this link you will be getting, and from tomorrow daily in your Google Drive, you can check for the videos. Please be in mute.
sir,
Right?
sir,
If
can
you
I
have-
ask?
Yes, please, 1 second. Give me a second. Right. Okay. Tomorrow, from tomorrow, right? The link, whatever link you are following. So a Google Drive, check in your Google Drive for the videos, right? Daily videos will be getting to your Google Drive, and notes you will be getting to your mail IDs. I'll be forwarding topic wise. Whenever that every week I'll be forwarding the notes to your mail IDs, what all we are discussing. And a WhatsApp group also will be created for this technical discussion, right? Three things: videos you will be getting, notes you will be getting to your mail IDs, videos to your Google Drive, and a WhatsApp link for any other discussion, technical discussion, other things, right? Fine. Yes.
Sir, when the videos will be shared, sir? Once the class is done?
Tomorrow a WhatsApp group will be created. From tomorrow itself, it will start. Videos will be shared tomorrow from your Google Drives. And
WhatsApp group will be
yes.
created on the class itself?
Tomorrow at the end of the class, I'll paste a link, WhatsApp group link in the chat panel. You can click it and get added right tomorrow itself. And from tomorrow in first Google Drive, you can just, if anyone not getting the videos, you can that online team details will be provided. Online team details will be provided. You can contact them if you're not getting the videos, right? Still, if they are not, still you can message me in the group. Still, if any, if they are not responding, like right.
Yes, sir. Can I ask?
Yes, go ahead.
Sir, I want to ask that PySpark is more in demand or Scala Spark?
Yes, PySpark today mostly used even in ML, right? Machine learning, right? Machine
Yes,
learning tasks. So even I won't say like both are equally used. I'm not saying, but these days PySpark mostly used. It has got more demand than Scala. Previously, if you see in 2016, 17, 18, 19, only Scala was used more. At that time, PySpark was less used, right? But from 2020 onwards or 20, you see like the usage of PySpark has increased. Even in ML techniques, in machine learning techniques, algorithms can be implemented, right? By using PySpark, right?
But sir, somebody told me that
yes,
PySpark is slower than Scala Spark, and as Spark is written in Scala, that's why Scala Spark is more in demand.
Yes, it's correct only, right? Scala is faster than Python, right? Scala is faster than Python. By default, Spark built by using Scala only, right? Yes, whatever you heard is correct only. Python is slower as compared to, even if you see comparison of Java, Scala and Python, Java is faster among all, next Scala and this, but Scala by default, what we say, Spark built by using Scala language, and the Python is slower as compared to the other two, right? But only thing, the advantage why we use PySpark or Spark with Python is, so we have got some libraries, special libraries available in Python, which can be used for machine learning, right? If you are going for machine learning kinds of activities where your application involves those things, we go for PySpark.
Sir, I want to go in the field of big data and in the big data engineering.
Yes, big data engineering means you need to have the knowledge on Spark. Implementing on which language, that is up to you, but Spark is an execution model. What the APIs remain same, data frames, RTDs in both the language, but only thing is the implementation is going to differ. And apart from this, Python has got some APIs available for machine learning. I'm saying. But Scala also has got APIs for machine learning, right? It can also perform this for streaming activities, for all those things. Scala also preferred. I'm not saying Scala is not used. Scala also mostly used, right? I can say like Scala, if I can say now, as per that 60 and 40, I'm saying Scala used 60 and PySpark used 40% in the industry. I'm not saying that you need to join this PySpark course, so that I'm not saying that you have to join with this PySpark. So I'm saying I'm not degrading Scala here. Scala is used more only by default. Scala is a language which can be used only for Spark, right? It is a native language of Spark. It is built for only Spark, right? No other environment using Scala except Spark, right? So by default, the Spark built a total APIs, whatever we see, right? Spark APIs or everything built by using Scala. And
Sir, if I will learn PySpark and Python, and I want to become a big data engineer, then is it sufficient, or should I learn
so if,
Spark also?
So if you go, if you go for, okay, even in the data science, right? Even a typical data scientist, right? It depend on this data engineer, right? For all these kinds of activities, what we do here, there, if a data scientist mostly like Python only preferred there for this kind of task, right? They won't go for Scala language, right? So, okay. And Scala means specifically for, there are some like big data engineering, right? If you go for data engineering kinds of tasks, where only they'll ask for Scala, right? You can go for it. So I'm not saying both are used 50-50%. I'm saying not like as you need to join this course. I'm not saying that you should only PySpark only used more. Not like both are used. Yes, it depends.
Thank you, sir.
Okay, fine.
Yes, sir.
Sir, I have one more note here, and here Dinesh here.
Yes.
Sir, can you provide any questions for interview preparation on
Yes.
PySpark?
Yes,
And
yes.
how to prepare and how to answer, which type
Yes.
of questions they will ask.
Yes, I can do that.
Sir, yeah, in this course, you will gonna to cover HBase and Hive also, or only PySpark only?
PySpark, but I can provide you the video, basic videos of Hive, right? Hive, how happens, because we are discussing Spark and Hive integration also there. How
Okay.
PySpark integrated with Hive. So for that understanding, I will be providing some videos of Hive, right? Basic videos, some 4-5 videos of Hive, not all those, right? So I can provide it.
Sir, again same road, sir. For data engineering, which one is better, sir? Whether Scala is Spark with Scala or PySpark is better?
See, 1 second. For data engineering, okay, you need to have the entire knowledge of Hadoop and Spark. You need to have the entire knowledge, means Hive should be there, Scoop knowledge should be there, right? See, basics of Hadoop's required, Spark also required. And even if you want tomorrow, if you want immediately you want to work with, so even if you see today, like the job opportunities for PySpark, means people with the knowledge of PySpark are very less, right? So so means the jobs are more for PySpark, means I'm not saying for Scala, but data engineering. And even PySpark is one of the hottest hot cake in the market, right? Very few people got updated with this PySpark, right? At this point of time, that's why people rushing towards PySpark, and even implementations also going right using PySpark. So I won't say that is your wish, whether you go for Scala. I'm not degrading any of this. Both are used equally in that as of now. But previously, totally Scala only used up to like before 3 years, right? Up to 2019, Scala is used most. But now PySpark, Spark with Python also used. So I already said the differentiations between Python and Scala, right? So both has got advantages, both have got some disadvantages. Both, I won't say that all this, okay, fine. As you said, right, Scala is faster as compared with Python. So
what is the duration of this course?
Duration of this course will be 10 weekends, right? 2.5 months.
Okay, sir.
Okay, fine. Yes. So still any other queries, right? Any other?
Sir, in this course, you gonna cover Hadoop or only Spark?
So that knowledge required for some of that, like some HDFS, some basic Hive, and for Scoop, right? I'll be providing the basic videos of it, right? Scoop videos, basic Hive videos, and basic HDFS.
Yeah, those videos are enough to clear the interview.
I'll be providing it, right, to understand these concepts.
Okay. Thank you, sir.
Okay, to enter this PySpark.
Okay. Thank you, sir.
Okay, so I'm stopping here. We'll continue tomorrow, right? More discussion on this. And as I said, tomorrow the link will be changing. And okay, fine. Anything Spark with Scala or Spark with Spark is the execution model you are implementing in different language like Scala or Python, right? Okay. See tomorrow same time at 4:30, right? Yes. Okay, fine. Thank you all for your time. Thank you. Yes.
Sir, one more question.
Yes, go ahead.
Sir, actually, you told prerequisite videos required for HD. I mean, Hadoop
yes.
and Hive.
Yes.
Yeah, can you share for tomorrow class before
no,
tomorrow class so that we can?
No, once you got enrolled, right? I'll be just keeping.
We already enrolled. Some of the people enrolled.
Tomorrow you'll be getting those videos, right? Tomorrow evening will be provided. Means next week totally you can go through that before we go to the next session of next Saturday, right? Fine.
Okay.
So what all the things, right? The notes or videos or those Hadoop basic those videos, everything will be forwarded once you got enrolled, right? Yes. So the separate Google Drive will be created that will be shared to all those enrolled students, right? Yes. Fine. Yeah. So I'm stopping here. Yeah. Any other queries, right? You can ask. Yeah.
Sir,
Clear notes. Clear notes will
for
be getting.
practicing, which software we gonna use, sir?
Yeah, I'll be demonstrating those about the software also, right?
Okay.
That the software also I'll be forwarding to your Google Drive.
Okay, sir.
Okay. Fine. Okay. Yes.
Okay.
So I'm stopping here.